moving the bushing from one service well to another to allow for final electrical testing. In order to move the bushing from one service well to another to allow for final electrical testing, 2 slings are choked onto the hoist crane that are attached to the flange. 2 inserts are placed on opposite ends of the flange, and 2 eye bolts are fastened onto the inserts. The 2 slings attached to the hoist crane are choked onto 2 separate shackles, which are locked onto the eye bolts. Wrap 2 tightening slings around the lifting slings on the upper half of the oil reservoir. This secures the bushing from falling when the crane is lifting it. Wrap the first tightening sling around the lifting slings on the upper half of the oil reservoir. The sling is wrapped around the oil reservoir through a buckle and tightened as much as possible. Wrap the second tightening sling around the lifting slings on the bottom half of the oil reservoir. The sling is wrapped around the oil reservoir through a buckle and tightened as much as possible. Once the lifting and tightening slings have been properly attached, the crane starts lifting the bushing out of the hole. While it is being lifted, a team member supports the bushing to keep it from swaying.
Okay guys, heading south.
Once the bushing has been completely lifted out of the well, use the crane to transport the bushing to the service well, where the final electrical testing takes place. The bushing is brought over top of the new service well. And carefully lowered into the well by crane. A team member supports the bushing from swaying while it is being lowered into place.
Yeah, we painted the entire bottom there. Yeah, we're going to turn it just on a nice, just like that, perfect. Perfect.
A ladder is then brought over so that the slings can be detached. The tightening sling on the upper half of the oil reservoir is unbuckled and wrapped off. The tightening sling on the bottom half of the oil reservoir is unbuckled and wrapped off. The final Megger and low voltage UST electrical test for capacitance and dissipation factor. To facilitate adequate transmission, a strand of 1/8 inch bare copper conductor should be tied to the top of the terminal. The flexibility of concentrically stranded bare copper conductor makes it very suitable for uninsulated electrical connections. Loop a section of strand around the rod twice, and then twist tie the ends together so that a connection clamp can be easily attached. To conduct the Megger test, the extended cable for the voltage lead can be connected to the conductor core via the threaded rod extending out from the top of the terminal at the top of the bushing.
Neato. No. It's just going to go to contact on the flange. There it goes.
That's a good number, right?
Yep, greater than 999. Yeah, see? It's not as good a connection through there. That's not grounded out properly. Or
Ensure bare metal is achieved by removing a small section of paint from the flange using a pneumatic drill with the appropriate attachment. Grind the paint off a section of the flange that extends from the base to the top of the crown, and grind both sides so that the connector on the cable lead can be clipped to bare metal. The capacitance and dissipation factor bridge used for double testing is situated on a dedicated mobile cart that should be stationed approximately 10 feet from the bushing being tested. The first test is the UST test that measures the integrity of the main insulation, also known as C1, between the conductor core and the winding that's connected to the capacitance tap. Connect one end of the ground lead to the terminal on the DF bridge. Connect the other end of the ground lead to the bare metal on the flange.
I think that.
Connect the low voltage lead to the terminal on the DF bridge. Connect the other end of the low voltage lead to the capacitance tap. Connect one end of the high voltage lead that sends out the electric current, the red lead, to the high voltage terminal labeled C(H) on the capacitance and dissipation factor bridge. Connect the other end of the lead, also red, to the bare copper strand wrapped around the top of the terminal lead. All of the cables are now connected, and the UST test can be conducted. Begin by turning the power switch to on.
Okay, it's on capacitance right now.
Dial the multiplier switch to select 100 on the picofarad scale on the left side. Dial the detector phasing switch to select C for capacitance.
Now I'm going to be adjusting this, trying to zero it out. Yeah, I think that works better.
Sure.
Okay, we've got our capacitance zeroed in now. Now we're going to go back to this switch and put it to DF, dissipation factor. Okay. Now I'm going to be going to this one here. And now we are at 0 to 1. Now I'm going to try bringing it up. Okay. Now I'm going to go back to this switch, check capacitance again. I got to fine tune that. Now I go back to this one for dissipation. Back to capacitance. Back to dissipation. And that should be zeroed.
Right on.
There they are. So that's our readings.
When the test has been completed, make the appropriate entries on the bushing test sheet as required. The final low-voltage GST electrical tests for capacitance and dissipation factor. To make the connections for the C1 plus C2 test, begin by removing the low-voltage lead from the capacitance tap. Remove the high-voltage lead from the connection to the bare copper wire on the threaded rod at the top of the terminal and replace it with the low-voltage lead. The cable is still supported through a sling suspended on the hoist hook. Connect the high voltage lead to the capacitance tap on the flange.
I'm going to put it down to GST.
What does GST stand for?
Grounded specimen test.
Go Bush.
Now I'm going to turn the power on.
Okay.
I'm going to start with the capacitance again. And now I'm going to try and find. Okay, it's not there, so we'll try that. We'll try that. And just increasing the multipliers. And there we go. We have it at 0.001. So now I'm going to okay, I have my capacitance. Now I'm going to go back to the DF. And there it is. Those are readings for capacitance. That's our readings for capacitance. We got 10.195. You can see the 10 on the dial there. Point, right there is your decimal point. 195. And then for your dissipation factor, you've got 0.457, we'll call it.
To make the connections for the C1 plus C2 test, remove the low voltage lead from the connection at the top of the bushing.
Yep.
Connect the low voltage lead to the bare metal on the flange. On the DF bridge, the selector switch should remain dialed to LGND, that is for the low ground GST test to be performed.
Yeah. UST stands for ungrounded specimen test. Okay, so we have this down to the GST. We're now going to turn on the power. We're going to do our capacitance test first. And you can see that it's high right now, so we're going to bring it down. We know it's there. So now we have that. Now we're going to do the DF. The DF is right around there.
Hey, Graham, you're affecting the test.
Okay, now the stairs are gone. It changes. Yep. There. Now we go back to capacitance. DF. No, it was minuscule, really it was.
So what are we looking at here? We're looking at...
Okay, now as far as the dissipation factor again,
Yeah.
we have 0.50. For the capacitance, we have 9.764, which is almost right on what our
exactly
prediction
what we
was.
said.
Yeah.
So if I were to just kind of walk near that now, when I
If I turned it on, yeah, it'll start. Oh, sure, absolutely, it'll fluctuate. You want me? I can do it for you. Let's put it on capacitance. There you go. See? I mean, you can even be right here, and it's actually, yeah, it's reacting to that. We've actually sent bushings. Actually, this one particular bushing here, like the Hebron 500, we sent it to ESSA, which is in Barrie, one of the main transformer yards.
Yeah. ESSA Township.
Yeah, and we sent it there, and they installed the bushing. I mean, we had excellent readings on it.
Yeah.
They installed it there, and all of a sudden they were having issues with the bushing, and they were going like, "What did you guys do? What did you know?" And there was, so they made us do all these other tests on another 500 that came in here, and what it turned out to be was the transformers in the yard around them that were all active were actually inducing
With the,
a current into their lines and into the.
Really?
Yeah, it was
Yeah.
like
That's
induction.
amazing. Yeah.
Test. The dissipation factor was 450, and it was at a scale of 0 to 1. which gives it an uncorrected DF of 0.450. The meter reading was 9.764 picofarads with a multiplier of 0.001, which gives it 9,064. So when you add 9,764 to 512, you come very, very close to your C1 plus C2 test. So it's just a confirmation.
The final high voltage UST electrical test, C1, for capacitance and dissipation factor. To make the connections for the C1 test, connect one end of the ground cable to the ground rod for the facility, located on the east side of the bushing shop. Connect the other end of the ground cable to the bare metal on the flange. Also, connect one end of the ground cable connected to the Biddle test set to the bare metal on the flange. Connect the low voltage lead to the capacitance cap on the flange. Place a rubber mat over a section of the floor and on the flange so that the cable attached to the cap tap rests on the mat. Attach the connector clamp to the high voltage lead that will be connected to the top of the terminal. Connect the high voltage lead to the top of the terminal by clamping it directly onto the threaded rod. This lead will deliver 10,000 volts into the rod it's connected to during the C1 test. The cable must be supported securely on the sling suspended by the hoist hook.
Because a lot of people are going to leave.
Yep. Oh yeah.
You need to capture it.
Rope off or use tape to seal the area and prevent anyone from entering it while the test is being conducted. Perform the C1 UST test using the Biddle test set and using the same procedure that was used for the initial electrical testing before the bushing was refurbished. This test is executed using a voltage of 10,000 volts.
So it's exactly 10 kV and the reading is below that? What's our reading?
I don't know. I can't see it from here. No, he's got 10 right now.
Yeah, he's got 10 kV.
Right on.
Oh, I see.
And our reading, it's going to take about.
Here it is.
There it comes. Okay.
0.45. That's the DF.
That's it.
Print it out.
Now he's going to print it out here.
Oh, right. That's right. All right.
And yeah, I got to get you a Doble sheet, I think. I don't know if there's one in there.
And write the serial number of the bushing on the record. Record the temperature and humidity readings on the appropriate form.
Good to go?
The final high voltage GST electrical test, C1 plus C2, for capacitance and dissipation factor. To make the connections for the C1 plus C2 GST test, disconnect the high voltage lead at the top of the bushing. Support the low voltage lead cable through the end of the sling suspended by the hoist hook above the bushing.
Yep.
and connect the strand of bare copper wire wound around the threaded rod at the top of the terminal. Connect the high voltage lead to the capacitance tap and rest the cable on the rubber mat and the block of wood on the floor below.
There you go.
Perform the C1 plus C2 GST test using the Biddle test set and using the same procedure that was used for the initial electrical testing before the bushing was refurbished. This test is executed using a voltage of 5,000 volts.
Oh, you're still taking readings?
Yeah, it make it easier now.
Oh, yeah.
It's easier because you're right there now.
Yeah, we got 0.45 this time around for dissipation. That's for C1.
It's right in here, so that's
Yeah.
that's all okay.
When the test is complete, print a copy of the results and write the serial number of the bushing on the record. Record the temperature and humidity readings on the appropriate form. Disconnect the low voltage lead at the top of the bushing. The final high voltage GST electrical test, C2, for capacitance and dissipation factor. Disconnect the low voltage lead from the top of the conductor core and connect it to the flange in preparation to conduct the C2 test. The high voltage lead will stay
Testing.
connected to the capacitance cap. The test is complete when a set of results appear in the display window and the red operation light goes out, followed by the red high voltage light, indicating that the high voltage switch has shut off.
All right. Okay.
Reconnecting the lifting jig to install the bushing onto the transport carrier. In order to connect the lifting jig to the bushing for placement in the transport carrier, begin by unscrewing each set of nuts and bolts connecting the crossmember to the lifting jig. Remove the crossmember and then loosely re-screw the nuts and bolts back into the lifting jig. Arrange the crane cables and the multi-point lifting beam in their storage crate so they are accessible for hoisting. Lower the hoist hook over the storage crate and connect the shackle on the top of the multi-point lifting beam to the hook.
Breakfast club on brown and a large double. No thank you, no nails. I guess that's it.
Using the shackles on the end of the two crane cables in the crate, attach the cables to each end of the lifting beam.
20 after 9, okay. Thanks a lot. Okay, bye-bye. 20 after 9. Good to walk too.
Eh?
Reach it all.
Yeah.
slowly begin to hoist the multi-point lifting beam with the cables connected out of the crate. Navigate the lifting beam to a point above the lifting jig so that the ends of the crane cables can be attached to the jig. Using the shackles on the ends of the two crane cables, attach the cables to each side of the lifting jig. Raise the lifting jig slightly off the ground and move it towards the bushing. Use duct tape to secure protective padding around the surface of the porcelain where it would come in contact with the metal jig. Use the crane to navigate the lifting jig in place around the porcelain. A team member should guide the jig into place and prevent it from swaying while being installed. Fasten the lifting jig onto the flange using the appropriate bolts and washers. One team member can hold the side cross-member section in place, while the other team member can insert and loosely attach the bolts to hold it to the lifting jig. Hand tighten the bolts on all four corners of the jig. Tighten each bolt using a ratchet wrench to secure the side crossmember to the frame of the lifting jig.
Liabilities.
Use the pneumatic air gun to fully tighten the bolts connecting the lifting jig to the flange. Shots of other bushings in work area, not related to this service project. Although the bushing that's presented in this module is a capacitance-graded bushing rated for 500 kilovolts and 1800 amps, there are many other types of bushings that will need to be refurbished in the bushing shop. During their very early years, bushings were in effect nothing more than a hollow porcelain shell filled with transformer oil and through which a conductor passed. Alternatively, they consisted of solid resins surrounding the conductor. Such simple bulk and solid type bushing designs are in fact still widespread today at the medium voltages and in some cases even up to 110 kilovolts. As electrical networks became more sophisticated, the need was recognized for a means to better distribute the electric field generated across a bushing, especially at the higher voltages. This resulted in the development of designs that were capacitance graded, or as the IEC definition for such condenser bushing states, in which the desired voltage grading is obtained by an arrangement of conducting materials or semiconducting layers incorporated into the insulating material. The basic principle was to try to distribute and equalize the natural electric field between the conductor and the earthed flange. This would be accomplished by employing intermediate conductive layers radially, in other words, to lower the field at the conductor so as to better utilize the insulating material, and axially, that is, near the flange, to allow for higher flashover voltages for any given arcing distance. Originally, the material used in the concentric cylinders wound around the conductor included resin-bonded paper as well as various carbon materials. Over the years, these were successively modified, leading to designs involving less conductive grades of plain paper along with aluminum foil. One of the major motivations behind the development of field-graded bushings was reducing the diameters required of the external porcelain shells. On ungraded bushings, the electric field tends to be concentrated around the flanges. Therefore, the risk of electrical breakdown becomes relatively high. By contrast, on fine graded bushings, the stress is linearized and spread out over a greater distance, resulting in a greater margin of safety. The impact of this is evident when one looks at a simple 110 kilovolt bushing. With field grading, the diameter of the porcelain housing required for this voltage class is only about 240 millimeters measured across the sheds. To handle the same stresses, an identical upgraded bushing would need a housing with a diameter of 475 millimeters, virtually double the size. 66.4. The benefits of a narrower external diameter include significantly lower cost for the housing, less transformer weight, and reduction of the required clearance diameter of the embedded shielding in the lower part, that is, by up to 40%. The latter two benefits translate into lower requirements for space, weight, and oil. Reinstalling the bushing onto the transport carrier and some troubleshooting issues. Lower the multi-point lifting beam with lifting cables attached at both sides to just above the electric hoist, and then attach the hoist to the crane hook. Unwrap the leads for the electric hoist from around the cart that the hoist is stationed on. Place a block of wood against the vertical metal posts on the side of the service well that the bushing is in. This will prevent the bushing from swaying when it is lifted out of the well. Attach the shackles on the ends of the lifting cables to the shackles on both sides of the lifting jig. Attach the hook on the electric hoist to the sling choked around the upper porcelain insulator below the oil reservoir tank.
Now, we got to make sure that this is very tight before we actually snug up that thing.
I just brought it back.
Yeah.
So I'm gonna put this down and just let me know.
Signal to the crane operator to remove the slack in the sling in order to avoid the hook from damaging the refurbished reservoir tank.
Yeah, that's it right there.
Inspect all the attachments and ensure that the bushing is safe to lift.
We're going to start lifting if you want.
Okay, go now.
Nice and easy. Just take her easy. Okay, go ahead. Very nice.
This thing has so much drop.
Yeah, you can go ahead and take her up. Yeah, you're smooth.
I've worked with some
Yeah.
guys,
Okay.
brother.
Okay, hang on, Sam. Just take it a little bit south now, maybe 2 or 3 inches, and we'll see how it plays out. That'll tilt it a bit more. Keep her going. Keep going south. Very nice. Very nice. Okay? Yep. Okay, you can take it up. Yep.
I was thinking, aren't you the rocks supposed to be this way?
No, sir. No, you didn't see it slide towards the block when you lifted it? Okay,
If you put it down, you put a rock over here.
yeah. Go south a bit more.
Okay.
A little more. Okay. Take it up.
That's clear right out.
Yeah, it looks very good. Go ahead. Oh, there it is.
As soon as the bushing has cleared the opening of the service well, replace the cover.
You say that angle what?
That looks good right there. Okay, now take it a little, take it north. And that's just about where you want it, right there.
With one team member controlling the crane and another team member controlling the electric hoist, the bushing can be tilted on its way toward the transport carrier.
Very nice. Yeah, just keep tipping. Yeah. That's just about perfect there, Sam. Oh, we can always take it out for now and then slide it because we've got this thing.
The bushing should be in the horizontal position at the side of the transport carrier in a north-south direction.
Yes, you are. No, you're perfect. Go west.
Slowly move the bushing west to be directly above the transport carrier.
Just go smooth. That's it.
Good job, pushing team.
Okay, you're just about. I'm just making sure that it's perfectly centered. The bushing is perfectly centered with the skid so that it'll be dropped into the right place.
When low enough in the transport carrier, the holes on the lifting jig must be aligned with the holes on the mounting flange of the bushing.
Now it's up to us. It's up to us where we're going to line it up. Yeah, come north. About 6 inches, 7 inches.
How'd you catch that hole?
Yeah.
Sam.
Yeah, it won't catch that hole.
Good.
We're already lined up with the one.
Get on an inch and a half.
actually, I'm lined up right here with a hole. See the furthest? Okay.
Let's just bring her down and have a look at it.
Yeah, but we've got to go. We got to go west about like that. Yeah, about an inch and a half. Right there. That should do it. That's where we got to line up, somewhere in that area. We're going to have to come down.
Bring her down, Sam. So let's pull it back up.
Well, hang on. What about? See this one?
In this case, the bushing and the transport carrier are not exactly compatible.
That one's nice there. See at the top? Whoop.
What do you have?
See, that's going to make us have us a problem.
Okay, well, we know we got an issue, we know how to deal with it. Take it up, we'll pin it.
And then we have to do it with the basket. Yeah. Bushing and this skid are not compatible.
Okay, so this
Lower the oil reservoir tank onto the rest at the top end of the transport carrier.
You can let your end down now, Sam. Okay. Okay, just let her down.
Arrange a stack of blocks onto which you lower the bottom porcelain.
Okay, we're going to let it sit on the porcelain. Nice and easy. Go ahead. Okay. Okay. What we can do is loosen the bottom, lift this off.
Use a ratchet wrench to loosen the 4 bolts holding the cross member to the lifting jig.
Oh, sorry. How close is that to the center of?
Of gravity?
Yeah.
When all 4 bolts have been removed, slide the cross member out from underneath the bushing.
Yeah, exactly. Yep.
Attach shackles to the top 2 holes on the mounting flange as it rests in the transport carrier.
Yeah, it just doesn't work.
Attach the sling for the lifting jig to the hoist hook and slowly raise the hoist hook to remove the slack in the sling.
Yeah, just make it a little, start to lift it a bit, just a fraction. That's good. Now you got it, that's it. Okay, Lloyd. We are ready.
Use a pneumatic air gun to loosen the bolts holding the lifting jig to the mounting flange of the
Yep.
bushing.
You got to do go up or down. Is this one? Straight up, Sam.
Begin to slowly raise the lifting jig off the bushing. Team members on either side of the jig should guide it up to avoid the jig from making any contact with the porcelain.
Okay. Yep, got her.
Move the jig into the concrete portion of the floor so that it stands on the 4 rectangular plates that were attached to the flange of the bushing.
Okay.
With a sling choked around the ground sleeve, remove the slack by raising the hoist hook. The shackles attached to the flange will not be required in this configuration. Raise the bushing slightly and remove the stack of blocks that the bottom porcelain was resting on.
You're already tight against the back here. Okay, I'm going to remove the blocks. Okay, you can start lowering it.
Lower the bushing back down in very small increments to line up the holes in the flange with the holes in the transport carrier.
Another half an inch or so. A little more. Keep it coming. More. A little more.
Insert the bolts with washers through the holes to secure the bushing to the carrier.
I'm going to Okay, that one's through.
Raise the plate on the end of the metal arm to meet with the base of the bottom flange on the bushing and reinsert the bolts to secure the plate.
There we are. Keep her coming.
Slightly raise or lower the bushing as required to fully secure the bolts that connect the flange on the bushing to the transport carrier.
Nothing is. Yep. How about this? How about this one? Done. Done like toast. Very nice.
Lower the hoist hook to just above the bushing. Remove the sling from the hoist hook and undo the choke around the ground sleeve of the bushing. Ensure the bolts are in place and secure where the metal arm is attached to the bottom flange of the bushing.
Looks good.
Remove the sheet of cork padding from the top of the porcelain. The refurbished bushing is now secure in the transport carrier and ready to be moved.
Now you tell us.
That's why we have a
Has the Sam? Has the tags been put on this bushing yet?
The other one I put on.
And the other one's on? Oh, okay.
Shots of copper draw lead conductor rods. When in service, a draw lead conductor rod like the one shown here is inside the conductor core of the bushing and carries the current from one end of the bushing to the other. In some cases, the draw lead conductor can be multiple pieces connected together. It's connected at the lower end to the transformer and at the upper end to a metal stud inside the terminal. When the bushing manufacturer supplies the draw lead conductor as part of the bushing, the current is limited to the rating specified on the bushing nameplate. The current rating on the draw lead conductor supplied with the bushing by the bushing manufacturer is dependent upon several factors. These are conductor cross-section and material, how the conductor is connected to the top terminal of the bushing, threads or multi-spring contacts. If the conductor is two-piece, the type of joint used, bolted or threads. Top oil temperature, oil level in the transformer, oil level in the bushing central tube, ambient air temperature.